Today, our goal is to determine the line of symmetry and vertex for a quadratic function algebraically. If you notice up top here, I have three parabolas, and we've been talking about them in class. And we've talked about the fact that parabolas are U-shaped graphs, is what we've talked about. But really, they're curved graphs. And they possess a geometric property that's called symmetry. That means that these can be folded in half so that each half matches the other exactly. So if I took a line and I drew that line going right here through the vertex, what I have on one side, if I could fold it over top of this line, would be the same as on the other side. And I could do that for all three of these parabolas. And I'm going to change that into a dotted line so we can kind of see what that looks like. Let's make it a little bit thinner. Dotted line, a little bit thinner. Dotted line, a little bit thinner. So what's on one side of the red line, on the left side, I've got the same thing on the right. And the same thing for each of these parabolas. So the fold line, this red line up here that I just showed you, is called the axes of symmetry for the parabola. Each point on the parabola that is on one side of the axes of symmetry, so if I look up here, right here, has a corresponding point on the parabola on the other side of the axis. So if I look up top here, on this parabola here, I have a point here, and it's the same exact point over here, except on this side it's positive. On this side it's negative. And it goes the same way all the way up. And we've talked about that in class today. So what we're going to do is we are going to, before we start to find out how do we exactly graph that line, I want you to pause up the video and I want you to graph these three graphs right here. Let me give you about 10 seconds and then I'm going to show you the answer. Now these are linear equations here. X equals -3, x equals 2, x equals -5. Hopefully you have taken that time to graph these. I'm going to do it very quickly. Right here with you. X is -3. So no matter what y is, x is always -3, which is going to be right here. And this one says x equals 2. So there's x2. And no matter what y is, x is always going to be +2. And for the last one, x equals -5, that would be right here, because no matter what y is, x is always -5. And if you notice, this line, this vertical line, is the same thing as my axes of symmetry on these parabolas. So what we're going to do is we're going to find out how to find that line. So for any quadratic of the form y equals ax squared plus bx plus c, remember we've learned this form in class, the equation of the line of symmetry is given by x equals negative b divided by 2a. Notice this negative is on the outside. So when we're finding this equation of line of symmetry, the negative is out here, and I'm going to do b divided by 2 times a first for finding that answer. So on your paper, I've given you this equation. Remember, a is what's with the x squared, so that's -3. Let me write that in pen for some of you. So this is the a, because remember the form is ax squared plus b plus c. So when I go to write my formula, y equals a -b divided by 2 times a. I'm going to plug in 6 for b and -3 for a. And it looks like that. And now I'm going to do 6 divided by 2 times negative 3, which is a negative 6. 6 divided by negative 6 is a negative 1, but I want a negative negative 1, which simply gives me positive 1. So our equation, sorry guys, having a little technical difficulty here. Let me do it this way. So our equation for our line of symmetry for this quadratic function is x equals 1. So if I was to graph this where x is 1, I have a vertical line. For our second example, which is on your paper, remember, this is A, this is B, and this is C. So I'm going to write down my formula to find the line of symmetry. X equals negative B divided by 2A. I'm going to plug in negative 4 for B because remember, the formula is plus B. So since this is a minus, that makes this 4 negative. So it's going to be a negative 4 divided by 2 times an A, even though there's no number there, remember that means 1. So negative 4 divided by 2 times negative 1. 2 times a negative 1 is a negative 2, so a negative 4 divided by a negative 2 gives me positive 2, but I want a negative of that. So x equals negative 2. That's my equation for my line of symmetry. So for this parabola, where x is negative 2, I would have that vertical line. Now we're going to look at how do we find the vertex? Because the vertex, which is our maximum or our minimum, depending on which way our parabola is opening, is the only point on the parabola that is on the x-axis of symmetry. This is why the x-coordinate of the vertex is given by negative b divided by 2a. Once we find this x-coordinate, which is also our equation for our line of symmetry, then I'm going to plug that value into my quadratic function to find the y-coordinate. So for our first example here, here's our quadratic function. Y equals x squared minus 8. So I'm going to first find my x value. This is A, and this is C. There is no B. We're going to use that x equals negative b divided by 2a to find the x-coordinate. Plug in my values. Since b is 0 divided by 2 times 1, I get x equals a negative 0, and there's no such thing as a negative 0, so it's simply x equals 0. And now I'm going to take this 0 and plug it back in to my quadratic function. Y equals x squared minus 8. So where x is, I'm going to plug in 0. And I get y equals 0 squared minus a. And 0 squared is simply 0. So 0 minus 8 is negative 8. So this quadratic function's vertex is when x is 0, y is negative 8. Which would be my maximum, because notice the A is positive, so that means it's opening upwards. So this is my, sorry, not my maximum, this is my minimum. And I should have written that down. So this is the vertex, but it is also the minimum of this quadratic. So this is the vertex, and it's also the minimum of this quadratic. We're going to do another example together. This is on your paper. Here's the quadratic function. So remember, since the vertex is on that line of symmetry, I'm going to find the x-coordinate by using our equation for finding line of symmetry. X equals negative b divided by 2a. This is my A. This is my B, and this is my C. So B is positive 4 divided by 2 times A, which is negative 2. 4 divided by 2 times negative 2 is negative 4. So 4 divided by negative 4 is a negative 1. But I want negative of that, so that makes x a positive 1. And now I'm going to plug that value back into my quadratic function to find out what the y is so I can find my vertex. So I write my quadratic function. Everywhere there's an x, I'm going to plug in positive 1. You can stick that whole thing in your calculator or using order of operations. I know that 1 squared is 1 times a negative 2 is negative 2 plus 4 times 1 is 4. So a negative 2 plus 4 is a positive 2 minus 5 is a negative 3. So my vertex, positive 1, negative 3, is my vertex. There's my line I'm looking for. And I notice that this quadratic, because a is negative, is opening down. So that also makes this, besides my vertex, it's also my maximum value. So now we've learned how to find max and minimum using a graph, and now we've learned how to find it algebraically, and to find the vertex on a graph, and now algebraically. So what I'd like you to do is solve these 4 problems, and then you're going to post your answers on Edmodo. When you go to turn in, type in your comment box the answers to these 4. We'll make this one question 1, we'll make this one question 2, we'll make this one question 3, and we'll make this one question 4. So I simply want you to type in your final answer. X equals, and then your ordered pair for 3 and 4. See you in class tomorrow.